Hello guys, today we are going to explore quadratic formula that is applicable to quadratic equation in the standard form. So actually that's the typical equation in the standard form. We have a, b and c are as coefficients and our goal is to solve that. How to solve that in general way. So we can hire the quadratic formula that has been developed exactly as a universal tool for standard equations, standard quadratic equations in this form. Okay, so how it works? First of all, I'm just gonna give you the way how you can calculate the values. So you just take in minus b plus minus square root of, and here you have specific thing what is called discriminant. You divide by 2a. So where d is specific expression that can be calculated through b squared minus 4ac. So that's why actually the step is the following here. First, you calculate a discriminant and trying to use that way, use your coefficient a, b, and c as numbers and try to calculate this value. After you've been calculated, the second step is to analyze. Analyze what? You need to analyze your discriminant because have a look at the formula. You have the square root of discriminant, and hence, because in the formula you have square root, so square root of discriminant only can be calculated in case when discriminant more or equal to 0. So that's why you need to analyze your discriminant, and if it's negative, you immediately need to stop yourself, because if you have negative number here, if discriminant is less than 0, it means simply that you are unable to take the square root of d. So that's why, and hence you'll get no solutions. So hence no solutions. You're just simply unable to get them. Alright, so that's the first case. So case 2, if d is 0, so simply according to the formula that you have here, you just take in minus b and add or subtract 0. So what it means, you subtract or add nothing. So that's why your solution is the single one. So you have a single solution here. So x is just simply minus b over 2a. That's how you calculate. And the last step, c, if discriminant is more than 0, so two solutions which you can calculate through the formula. You just take in the square root of discriminant and divide by 2a. Okay, so that's actually the steps that you need to take in order to get to your solutions. But first, the critical thing here is to analyze discriminant. So you always need to analyze your discriminant. And then after that, decide what picture you have in your round or in your particular case. Okay, so here I try to derive the formula. So I try to explain why this formula works exactly in the same manner, why it's not something else. So here I'm just going to prove, and let's go there. So we have x squared plus bx and plus c, and we would like to prove that x can be calculated. Instead of discriminant, I just simply used the full formula. It's b squared minus 4ac, that's the value, stays instead of discriminant, and over 2a. Okay, so let's try to start doing that. I'll be using quadratic complete square. So I just want to complete the square. So make sure you understand how it works. If not, just try to watch my video dedicated to completing the square. Actually, I provided several ways there. Okay, and from what we know, we just simply need to everything divide by a, and hence we'll get this. So what I'm doing, I take both parts divided by a. So of course in this case a is not be able to 0, and obviously in the formula 2a in the denominator, so it's obviously clear that a is not equal to 0. Alright, so we've got this expression, and we would like to know the following. So b over a, c over a, just coefficients, just numbers. What are we gonna do right now? I just want to take and provide a complete square formula. So as far as you remember, the completing square looks like, because we have plus, so positive sign with the mixed term x, so we just simply need to use plus in the formula, and let's say I put some k value here, or h. Let's say h is better, because as I remember I used h before. Okay, so we need to have this. That's what is called complete square. Okay, so let's try to expand that in order to make sure we have the right structure. 2xh and plus h squared. That's how the formula works. If you don't remember like why it's so, just try to take x plus h and times itself, x plus h. That's how it works now. Alright, and you'll come after some sort of simplification, you'll come there. Okay, so now what I'm gonna do, I'm just gonna take this structure and compare it with what we have. So we have x squared plus b over a x. We have something in the end, but we don't care, because right now the significant part is here. So we're gonna take also this part in the same form. So instead of 2xh we have b over a. So looks like in order to guess what h is, we just simply need to add 2 and immediately divide by 2, so that the answer is not changed and this part stays the same as b over a x. Okay, however, now we have the structure. So let's compare the term 2h, so like coefficient before x, 2h should be equal to the term 2b over 2a now. So those two coefficients the same. So that's why we can say that 2h is simply 2b over 2a. From where, if we divide both parts by 2, we'll get the following. h is equal to b over 2a. Alright, so we got that. And now we know what h stands for. Okay, b over 2a value. So that's why instead of this, we just simply can write the following. X squared plus, I just write in 2 b over 2ax, and then we need to have, according to the formula, h squared. So we add h squared, which is b over 2a squared, and now we have a complete square here. But we also need to subtract this term immediately, because we're not going to have our original expression to be changed. So that's why we subtract b over 2a squared. Okay, so I just simply erase that to have space. And we need to add also c over a term, the last term that we have. And now we have rearranged expression from here. We just simply arrive to the bottom part and where you have the completed square. Alright, so let's move next. This is what is called completed square. So we have x plus b over 2a, which is squared, and then we also need to have the following term, c over a minus b over 2a squared. Okay, so we equate to 0, and now it looks like you guys understand that we need to arrive to the simplest form of quadratic equation. So we just want to take the simplest form of the quadratic equation. So just remember, it was x squared equals k, where k is some positive number. So k is just simply positive number or zero number. So in this case, we just simply take the whole rest term, what is called free coefficient, and we transfer to the right side. So we'll get x plus b over 2a, which is squared, is equal to, by changing, just transfer, and we change the sign, b over 2a, which is squared, minus c over a. Alright, so now let's compare it with the simplest form. We have that, and looks like this is k, and this your left hand side. So you can say simply that if you mark as t, what stays in the brackets, you'll get the following. So if t is x plus b over 2a, you'll get the following: t squared equals, and if you mark that as k, you'll get equals k. So right now you reach the simplest form. That's the simplest form of the quadratic equation. So what to do next? What we're going to do next? We just simply need to say that t is plus or minus square root of k. So instead of t, we just move back to what we have in terms of x. So we'll get x plus b over 2a is simply equal to plus or minus, and square root of k, so square root of these expressions, like b over 2a squared and minus c over a. Okay, and from where we need to express x, so just simply express x value. So if we express that, we'll get the following. So x is equal to minus b over 2a, then plus minus. And here what I'm going to do, I'm going to square up and come to the common denominator. So if I square up, I'll get 4a in the bottom part. Okay, so here I'll get b squared, and because we have a but not 4, so what we can do, 4a squared, and we have only a, right? We just need to say, okay, squared multiplied by a, multiplied by 4, multiplied by 4 to the top part. If you cancel, you'll get c over a anymore. So anyway, and however, now you have common denominators for a squared, and they are the same. So that's why you subtract 4ca or 4ac. Okay, so you can understand that right now it very looks like the quadratic formula. All right, let's move next, and we can change in the following manner. So minus b over 2a plus minus, and then I take square root of the top and from the bottom part as well. But if I take square root of 4a squared, I'll just come back to 2a, right? Because it's going to be square root of 4 and square root of a squared, which is 2a. And now I just simply combine them in one whole fraction. So I'll get minus b plus minus square root of b squared minus 4ac. So here, the thing that stays under the square root, this expression is the discriminant. So just remember b squared minus 4ac. Okay, and I divide by 2a. That's actually, we derived the formula for how to find x if you're given quadratic equations in the standard form. So one more time, it's applicable to equation that's set up as the following: x squared plus bx plus c equals 0. Okay, so we've made the proof, and right now what we're gonna do, so just let's compare for certainty that we proved that. Yes, we have it here, and we've proved. Okay, so let's move and try to explore some examples. Now that's the formula I want to apply this formula in order to solve something. Okay, so let's take simple example. X squared plus 3x plus 2 equals 0. As you remember, you can do through factorizing. If you factorize that, you'll get the following: x plus 2 and x plus 1 equals 0, and solutions are -2 and x equals -1. Alright, so now let's apply quadratic formula in order to get the same answer. So one more time, we have quadratic formula as this one, and so to apply that, you obviously need to understand what your coefficients. So you just put below coefficients, or just standard formula, right? Standard quadratic formula, and then you just simply compare it. So A is simply 1, B is simply 3, and C is 2. Okay, now you know the values. Now you need just apply the formula minus B plus minus square root of discriminant. And the first step is to calculate discriminant. So discriminant, which is B squared minus 4AC, would look like B squared is 3 squared is 9 minus 4 times 2 times 1 is 8, and we'll get just 1. So 1 is positive number, so discriminant is more than 0, so we should have 2 solutions according to our roadmap. So 2 solutions here. And the second step, calculate solutions according to the formula. We'll get the following: minus b plus minus square root of discriminant. So we're just writing minus b is minus 3 plus minus square root of 1 and over 2 times 1, which is 2. So if we simplify that, we'll get minus 3 plus minus 1 over 2. So from where we have x1 solution, so we taken, let's say, positive sign first, and calculate minus 3 plus 1 is minus 2 over 2 is 1 with the minus sign, so it's -1 here. Okay, so we've got that solution. Next one, we take the next step, minus 3 minus 1, we'll get minus 4 over 2, and finally it will be -2, so we've got the second solution. So you might ask why to do so if you can factorize. I'll tell you soon where it works perfectly, and without that formula it's less likely you can do that, except for you just complete a square, then make a difference and just calculate through it. But I think in this case quadratic formula is much more appropriate. So let's consider this example. X squared, I say minus 2x, and I'll say minus, for example, even 2 if you take. Alright, so if you start thinking about factorizing, you'll hardly can pick up coefficients A and B. So that method doesn't work. So doesn't work because it's less likely you can find out A and B. So actually they do exist, but it's less likely you'll find them because actually they're gonna be in third form, and we're not whole numbers, integers, but instead they're real numbers like thirds. It's less likely you can do that. So you're just taking the quadratic formula and write, okay, x is minus b plus minus square root of b squared minus 4ac and over 2a. So I know that a is 1, b is -2, and c is also -2. So I'll just simply plug that in the formula and I'll get the following. So I'll get 2 plus minus b squared is 4. Next, minus 4ac, I'll have plus 8. 4 times -2, and minus will give you plus, so over 2. So let's simplify that. And now you'll see that square root of 12 is the third. You can simplify a little bit like this, because square root of 12 is square root of 4 times 3, and that's simply 2 square root of 3. If you just remember how to cope with surds, that's how it works, and you'll get 2 square root of 3 over 2. And now you can do the following. So actually it's forbidden to cancel like that because you remember it doesn't work, so you need to factorize first, and then you can cancel by 2. So now canceling works because on the top you have factors, but not like the terms that you add in or subtracting as in this case. So finally you'll get solution in the form 1 plus minus square root of 3. And you understand that because solution for x, so let's write one more time. So solutions for x is 1 plus minus square root of 3. They actually contain surds, so this is exact form or surd form. So if you want to calculate, so for example, you might give your answer to 2 decimal place. Let's say 2 dp here. So what are you gonna do? You just take in calculator and simply calculate. So square root of 3, as far as I know, it's 1.71 or 73, but let's check it. So first, 1 plus square root of 3. So the first solution is 1 plus square root of 3, which is 273 and like 2 something. Okay, we have 2 decimal places, so we round up to second digit after the decimal point, so we'll get 273. So the second solution was the minus sign, and we'll get negative okay, right completely. So it's going to be 1 minus square root of 3, which is simply negative 0.73 to something. And again, if we round to 2 dp, we'll get negative 0.73. All right, so that's in the case you want to calculate and you're obliged to give your answer in the decimal form to 2 decimal places. Okay guys, so hope you enjoy, hope you like satisfied with the proof. The proof is not probably like the easiest way, but however, it's what I know, it's a pretty nice way because you remember the completing square, what it means by definition, and simply we explored recently, we've just explored the quadratic formula, how it works, what discriminant is, and what to do in order to analyze how many solutions, because in some questions and problems you just might be given the estimate for how many solutions this equation might have. Hope you enjoyed. Don't forget to subscribe. That was Daniel Dallas, and see you later, guys.